So today we're going to cover the last section of chapter 11, section 8, and today we're going to learn how to calculate the volume and the surface area of a sphere. So first we're going to define what a sphere is, and the sphere is the set of all points in space that are equidistant from a given point, and that given point will be the center. So each of these pictures are showing us different parts within our sphere. What we're going to need for both formulas is the radius. So if they give us a diameter, we'll need to divide it by 2. Now that bottom picture with that pink plane that is slicing that sphere, once that plane intersects the sphere and it goes through the center of the sphere, that intersection is called the great circle of a sphere. So if you ever see an SAT question about the great circle, that is how it's formed. Now, real life examples of spheres could be a globe, it could be a basketball, could be a baseball, softball, any type of ball is represented by a sphere. If you think about the Earth, the imaginary line that would go through the center of the Earth is called the equator. And the equator separates the Earth into 2 hemispheres. So that would be like dividing our sphere into 2 parts. Let's go ahead and take a look at our first formula. And it's the surface area formula for a sphere. And that formula is 4 times pi r squared. So it's the area formula of a circle times by 4. And again, you will need to have the radius length. If you're not given a radius, let's say you're given a diameter, just remember to divide it by 2 to turn it into a radius. The volume of a sphere is 4/3 pi times the radius cubed. Notice this time our radius is raised to the 3rd power instead of squared. Now, one thing that you could do maybe to simplify things with your calculator use, you could, instead of multiplying it by 4/3, you could do 4 times pi times the radius cubed, get that answer, and then divide it by 3. Again, practice with your calculators. Whether or not you need to use parentheses, know when you need to hit the enter button or the equal sign in order to get the correct answers. Let's go ahead and do several examples using these 2 formulas. Okay, so here it says to complete the table for spheres, leave your answer in terms of pi. I'm actually going to go ahead and give you the decimal version answer as well, because I've decided on the quiz on Tuesday, all answers will be rounded to the hundreds place. However, in the homework, when you're filling in, I think it's question number 17, when you're filling in that chart, it wants it to be left in terms of pi. So let's go ahead and fill this in. So for number 1, they gave us a diameter. We need to turn that into a radius by dividing it by 2. So 12 divided by 2, and my radius is 6. The surface area, and let me go ahead and write the formulas up above so I have a quick reference for them. The surface area formula, which is also known as total area, is 4 times pi r squared. Remember, the units for all area questions are units squared. The volume formula for this sphere is 4/3 pi times radius cubed. Remember, the units for volume are going to be raised to the 3rd power. So for the first question, to find the surface area, 4 times pi times the radius squared. Once I multiply, I get 144 pi. And again, these are units squared. But if I want to round this answer to the hundreds place, 144 times pi will give me 452.39. And these again are the units squared. For the volume, 4/3 times pi times 6 to the third power. Once I multiply all of that, left in terms of pi, it's going to be 288 pi units cubed. If I multiply 288 times pi, I'm going to get 904.78. And again, both of these are units cubed. For the next one, they gave me the radius. I need to double it to turn it into a diameter. And now that I have my radius is 7, I'm going to plug it into the formula. So 4 pi times 7 squared will give me 196 pi. Multiplying 196 times pi gives me 615.75. And again, these will be units squared. For the volume, 4/3 pi times 7 to the third power. Once I multiply this, left in terms of pi, I'm just going to go ahead and leave it as an improper fraction. 1,372 over 3 pi units cubed. But again, on the quiz, I will expect you to turn it into a decimal. So 1,372 divided by 3 and then times by pi gives me 1,436.76. And these again are both units cubed. Now for numbers 3 and 4, they're not giving me a radius or a diameter. They're asking me to work backwards from both. For number 3, work backwards from the volume, and for number 4, work backwards from the surface area. Now, on number 3, my comma is in the wrong place. It's a typo. That should be 32,000 pi over 3. So I'm going to go ahead and work out number 3 down at the bottom, so I have more room. So they're giving me the volume, and it's equal to, again, remember, it's 4/3 pi times radius cubed. So I'm going to go ahead and set that equal to what was given to me. So let me go ahead and erase the capital V and put in what it equals. And that's the 32,000. Again, my comma's in the wrong spot. 32,000 over 3 pi. Now, I need to go ahead and start doing some inverse operations here to go ahead and isolate my radius. Because in order to calculate the surface area, I need to figure out what the radius is. Now, these inverse operations, you can do them in any order. I'll go ahead and get rid of the fraction first. I could times both sides by 3. That will cancel the denominator on both. And now I'm left with 32,000 pi equals 4 pi radius cubed. I now could, and in one step if I want, just divide both sides by 4 pi. That will cancel the pi's. And it also cancels the 4's. So then 32,000 divided by 4 gives me 8,000. And that's equal to r cubed. And now I have to cube root the 8,000, which gives me 20. So my radius is 20. My diameter, I'm going to double it, and my diameter is 40. I also need to find the surface area for number 3. The surface area formula is 4 pi r squared. So now that I have the radius, I'll put 20 in here, and I can square it. and that gives me 400. 400 times 4 is 1600 pi, and these are units squared. The radius over here is units, and so is the diameter. Not squared, only the area is squared. And then if I wanted to round my surface area to the hundreds place, 1600 times pi gives me 5,026.548, so 0.55. And again, this one is also units squared. For number 4, what was given to me was the surface area. So I needed to fill in the rest. So up here, I could fill in for number 3. My diameter for number 3 was 40. The radius was 20. And then here was just 1600 pi. And then the decimal is down at the bottom. Now, for the next one, they gave us the surface area. So for number 4, surface area is equal to 4 pi r squared. So again, I'm going to erase the surface area, the SA, and put in what they gave me. They gave me 12 pi. I can go ahead and divide both sides by 4 pi. This gives me 3 is equal to the radius squared. I don't want radius squared, I want the radius. So square root it, and the radius is equal to the square root of 3. For the diameter, you have to double it. And these are both units. Now to calculate the volume, for the volume for number 4, 4/3 pi times the radius to the third power, 4/3 pi times the square root of 3 raised to the third power. And then here, in terms of pi, for the square root of 3 raised to the third power is just going to be 3 square root 3. Notice these 3's would cancel. So the volume left in terms of pi is going to be 4 square root 3 pi. Really, the order doesn't matter here if you wanted to write it that way. But rounding to the hundreds place, multiplying 4 times pi times the square root of 3 is going to give me 21.765, so 0.77, and these are both units cubed. Now, for number 5, since they gave me the radius as just an r, really all I'm doing is rewriting the formulas on number 5. So for the chart here, remember this one was 2 root 3, this was root 3, and then this one left in terms of pi, 4 pi root 3. Over here, to make a radius into a diameter, double it. And then for the surface area, since r is r, just rewrite the formula on both of these. On the quiz, I'm not going to give you a variable for the radius. I'm going to actually give you a number, and you'll have to calculate it using the formula. Then for the last one, we're going to double the radius, so this becomes 4r. And then when I plug it into the formula, 4 pi 2r squared, this becomes 4 pi times 4r squared. And then when I multiply this, I end up getting 16 pi r squared is the surface area. And then for the volume, 4/3 pi times 2r raised to the third power. Once I do this, this becomes 8r to the third times the 4/3 pi. And then once I multiply all that, I get 32 over 3 pi times the radius cubed. Now, it wants me to compare on numbers 7 and 8, the two surface areas on number 7, and then number 8 wants me to compare the two volumes. So for number 7, the surface area for number 5 was 4 pi r squared. The surface area for number 6 was 16 pi r squared. If you compare what they did from number 5 to number 6, this was number 5's answer, this is number 6's, what they did to go from one to the other, it was multiplied by 4. Or if you think about it, it's the area squared. So then number 8, they want you to compare the volumes. 4/3 pi r cubed is the first one from number 5, and then 32 over 3 pi r cubed. Notice this one was multiplied by 8. So again, this is like taking our r, and what we did was we cubed it. Because 2 cubed, that's how we got the 8. So number 2, it says the number of square centimeters in the area of a sphere is going to be the same as, so it's going to be equal to the number of cubic centimeters in the volume of a sphere. Find the radius of the sphere. So what this is really telling us is all we have to do is set the two formulas equal to each other. So I'm going to set 4 pi r squared, the surface area formula, equal to the volume formula. So I'm going to go ahead and start doing my inverse operations to get my r's together. I could go ahead and divide both sides by pi. I'll do it step by step so nobody gets lost. That would cancel the pi's on both sides. So now I'm left with 4r squared equals 4/3 pi radius, oh no pi, sorry, let me get rid of the pi, it was gone, r cubed. Now I could also divide both sides by 4, which would cancel both 4's. So now I'm left with r squared equals r cubed over 3. I'm going to multiply both sides by 3 to get rid of the fraction. You could have done this earlier in the problem. Doesn't really matter. So now I have 3r squared equals r cubed. My goal is to get and solve for r. So I'm going to divide both sides by r squared. Remember, when you divide variables with exponents, you subtract them. So r to the third divided by r squared is really 3 minus 2. And you just get r to the first equals 3. So the radius would need to have a length of 3 in order for the surface area and the volume to be equal. Doing this number 2, again, you could have done your inverse in different steps. You didn't have to divide by pi first. You could have multiplied by 3 first. Again, just know that you had to isolate the r. Let's do the last example. It's a composite solid. So in order to find the volume of this ice cream cone looking thing, so the volume of the composite solid is going to be equal to the volume of the cone plus volume of half of the sphere. So what I'm going to do is go ahead and fill in my two formulas. Volume of a cone is 1/3 pi r squared height. Half of the sphere, so the volume formula for a sphere is 4/3 pi r cubed. And I need to divide that by 2 or multiply it by a half. So let's fill in what we know. We know the radius is 1. So 1/3, 1 squared. The height of the cone is 5. The radius of the hemisphere is the same as the cone, it's 1. So 4/3 pi times 1 cubed. And now let's go ahead and simplify some stuff. So this becomes 5/3 pi because 1 squared is just 1. And then over here, this will become 2/3 pi. I can add this together. I get 7/3 pi. Now, if it wanted left in terms of pi, this would be meters cubed. However, using your calculator and multiplying 7/3 times pi gives me 7.33 meters cubed. And this would be the volume of our composite solid.